Yesterday, hi guys. Yesterday, what we discussed up to?
Start with the transport layer, TCP and UDP.
Okay,
4 layers,
up to
transport layer.
fine, good. And can anyone answer it? What is R?
The address resolution protocol.
Good.
Address
Address
resolution protocol.
Uh,
And
Good.
it saves the MAC address from different
Good.
computer.
Anyone answer it? What is the difference between TCP and UDP?
TCP is connection oriented, UDP is connectionless orientation.
Good.
TCP supports acknowledgements and UDP doesn't support acknowledgements.
Good. Anything
Uh,
else?
Reliable communication protocol, and the UDP is unreliable communication protocol.
Okay. May I know the reason TCP is reliable protocol behind any processes work?
Three-way handshake.
Define. What is three-way handshake?
When a PC pings another PC, like it synchronizes the packets first, and the other first it will synchronize the packets, and the other PC will send a reply by synchronizing an acknowledgement, and then the first PC reply back saying acknowledging the synchronize and acknowledgement.
PC to server, client to server. Whenever we are discussing, whenever we are answering, like client machine and server machine. Client machine first send the sync, and server machine sync plus add, plus, then client machine received, then it will be acknowledged with that packet. Likewise. Good. Fine. Any doubts up to here? Anyone having any doubts? Fine. Thank you for the confirmation. Fine. Here it's OSPF we had discussed yesterday, like its reference model and established it. ISO is established it 1980, and it's developed ISO. Then it consists of 7 layers. It's TCP, physical layer, data link layer, network layer, and transport layer. Up to this 4 layer network engineer will work. These session layer, presentation layer, and application layers, these all are the for software layers, user support layers. It means whenever we are using web browser, in that web browser, it's kind of application only. In web browser, can use the multiple applications like Facebook, and whichever we require, bank websites, whichever we need. Like behind that, it can be we'll use like port numbers, HTTP having port number 80, HTTPS having port number is 443. It's secure. With the help of HTTP and HTTPS, we can access the any websites with the help of port numbers only. And okay, we'll start from session layer. What is the session layer? What is the session layer? A session layer is responsible for the creating the sessions and terminating the sessions. Okay, and it will be create the session and terminating the sessions likewise. Whenever you are using any web browsers or any, like if you are using a web browser, in the sense that's application layer. Now coming to our network technology, whenever we are using telnet, SSH, with the help of remotely connected to our routers and devices, there it will be establish this session. Okay, establish this session, like if you are not doing anything, if you are not performing anything, the session automatically terminate after few minutes. That is called session layer. For example, in real time, just you logged in one web bank website. In that bank website, whichever you need transaction, you check everything, you check. After then, while minute you are not checking, that time it will be automatically log out, shut down it. Your session will be completed. You will get some acknowledgement. You will get some error kind of message. Have you got anytime? Likewise, it's kind of session layer. Whenever you are using any session in our network, there we have a session IDs. We'll discuss more about it. Just write this. Session ID is used to identify a session or interaction. Likewise, like in BGP, we having like keep alive messages. It will be sent always. If neighbor or peer is not given response, then that session will be automatically down. This kind of sessions will be established in our network technologies. Understood everyone? Session layer.
Yes, sir.
Good. Thank you for response. And presentation layer. Move to the presentation layer. In presentation layer, we have a data like encryption and decryption, and it will be deals with data presentation, whichever we are giving, we are advertising data. User is connected to some browser or somewhere, and then he text message to with the help of SNMP. Sorry, he is sending to mail to other person. There in this presentation layer, what he will send simply, he'll send hi at PC 12 and PC 2. Hi, myself, something he will send myself PC 1. And the time the text message will be like uh, it will be encoded. It form will be like it will be more likewise. Whenever the up with the help of application layer, it will be whichever he use mail protocol, simple mail protocol. Then in that simple mail protocol, the text will be moved to the presentation layer. Whenever the presentation layer come, the presentation layer, it will be send data likewise, like PC 1, my hi. It will be likewise self. It will be sent not a form, correct form. Okay. Whenever it will be received to the application then session, then net presentation, then after network, then data link layer, then it will be moved to the physical layer. Then it will be come to the likewise upper layers. It will be moved to the state. It will be come to the likewise. Then it will be presentation. It will be moved to the physical layer, connectivity. With the help of connectivity, the data came, and data link will be checked. The process, whichever IRP is getting is correct or not, it will be checked. Then it will be give to the which IP is getting. It will be taken. Then it will be moved to the transport layer. Then it will be session layer. Then presentation layer. Here the data is like encoding. Okay, encoded. Then whenever this PC is received, that time it will be decoded with same layer, presentation layer only, decoded that information, decoded. Then that time, hi myself PC1, this information will be hi hi myself PC1. Then this PC1 will be replied to this one. Encoding and decoding process, it will be likewise. Any doubts? Encoded from here and decoded from here. Decoded the PC2. The form, the whichever the data is sending likewise. PC, myself, not a format is perfect. But whenever the data received, the receiver will be, it's a sender and it's a receiver. Whenever the data is received, the presentation will be again, it will be sent likewise, and receiving time it will be decoded, encoded from here and decoded from here. Fine. Anything, any doubts? Encoding and decoding. Fine. And move to the encryption and decryption also here only, in this layer only, in presentation layer. The data will be encrypted and decrypted, encrypted and decrypted form likewise. It will be star, hash, like this. The data will be, whenever I am sending hi myself PC1, the data, it will be not go likewise. It will be encrypted form, like star, hash, likewise it will be more 1 2 3 likewise. Encryption also, decryption also here on. Encryption and decryption, like for example, the data will be high, in the sense it will be more hash 0 a, likewise c 1 hash star. It will be whenever the PC1 is sending, then PC2 is received. That time the form, in this segment likewise, the encryptor will be formed. When the PC is received, PC2 is received, that time it will be decrypt the data. Likewise, whenever the application presentation layer, it will be sent likewise. It will be sent likewise down to top to down, and it will be get like, and bottom to top. Physical data link here, application from starting from application and ended to physical layer. Here starting from physical layer, whenever the PC is received, PC2 is received, that time it will be application. The decryption, encryption and decryption will be at presentation layer form. This presentation here encrypted the data, this form, and whenever the received, that time it will be encryption and decryption, encoding and decoding. It is a text format, like it will be text format, and the data will be encryption star hash, likewise you can. Now move to the presentation. Presentation is layer is done, and now move to the who knows what is the application layer discussed. And it is responsible for the end user information. Take care about it. Examples we discussed: telnet and SSH, and more examples are so there. Now for timing, guys, up to here, any doubts, any queries? All good. Fine. Thank you for confirmation. And now coming to the TCP IP model. TCP IP model. Again, same transmission control protocol. TCP IP is nothing but transmission control protocol. TCP stands for transmission control protocol, and IP in the sense internet protocol. And what is the main difference here? It's OSI model is for open system interconnection. It is a reference model for reference purpose, but TCP IP is a implementation model. Okay, TCP IP model is a implementation model, and the created by DOD, Defense of Department of Defense Organization. Just write this. And the main difference here is only OSA model having 7 layers, but TCP IP having only 4 layers. The main application layer, presentation layer, session layer, these three comes under only application layer. The heart of OSA model is transport layer, that is host to host communication. Like here we are using mainly TCP and UDP. It is responsible, and transport layer also is responsible for the identify the service with the help of port number. With the help of port number, identify service, which service is coming from upper layer, like which service is coming from upper layer. With the help of port number, we discussed HTTP having port number is 80. HTTPS having port number is 443, and Telnet having port number is 23. SSH having port number is 22. And network layers here will use IP addresses and routed protocol and routing protocol. Same thing here. Routed protocol in the sense IPv4 and IPv6. With the help of routed protocol, it will be carry the user information. It will be carry the user information. And examples is IPv4 and IPv6. These are our routed protocols. And routing protocols here we having, it will be select the best path with the help of cost, with the help of metric values. EAGRP use metric values like k values like band, k1, k2, k3, k4, k5, load balance, load delay, reliability, MTU size. This comes under here. And one more thing, RIP uses the hop count. It's a legacy protocol. Nowadays, no one is using. EAGRP is Cisco proprietary. EAGRP is Cisco proprietary. Now OSPF is most of the organizations will use. And one more protocol also is there, IS, internet service like this. This will be used as mostly ISP, internet service providers will be used this protocol. Internet service providers like Geo, AT&T. Okay, this kind of big organizations will use this protocol. No, not much more required to learn, but OSPF is necessary, and EAGRP, and brief about RIP and EAGRP will discuss. We'll discuss more about IGP protocol, that is OSPF. Okay, understood? Good. And one more protocols also is there, EGP protocol, that is yesterday have given EGP protocol, that is BGP. Only brief introduction. It's statically will configure. It's not a dynamic protocol or routing protocol. BGP, border gateway routing protocol. Border gateway protocol, BGP. These are comes under internet. Now move to the network access. Here we have like ARP, address resolution protocols, STP, spanning tree protocol in this layer 2 protocol, FHRP. Switches will work here and routers will work network layer. Routers will work network layer, and here switches will work, hubs will work, devices, firewalls also here. Guys, any doubt till up to here? And what we'll do, I'll give you a brief introduction. Like here in we have in application layer we have HTTP and telnet we had discussed, and one more protocol also we have FTP, file transfer protocol, TFTP, it's legacy protocol leave it, and SNMP, simple network management protocol. These all will work best example for uh, application layer. Oh. Address resolution protocol with the help of R will be work in layer 2. I'll give a brief introduction. R address resolution protocol. R work in layer 2, and with the help of ARC will resolve the IP address to MAC address. Like here we have a PC1 and PC2. PC1 then one frame packets to PC1. Filter will do. PC1 and PC2, and in between one layer 2 switch is there, L2 switch. Here switch, switch PC1, PC2. Connectivity likewise. A Cisco packet tracer, I will show you the. Here PC1 having MAC address is a MAC address having 48-bit number, and IP address is like this PC having IP address is 192.168. There's both PCs are in same network. If I am taking here same network, 1.2/24. Whenever I'll try to ping this IP to PC1 to PC2 with the help of IP address, it's like 192.168.1.2. Then PC1 don't know the PC2 MAC address. We know the IP address, but switch will maintain the MAC table. With the help of MAC table only, they can communicate to each other. In layer 2 communication with the help of MAC address only, they can communicate to each other. But that time PC1 don't know the PC2 IP MAC address. Understood? Then it will be find out with the help of IP address with here ARP address resolution protocol. And one more ARP also we have reverse ARP, RARP. With the help of RR, we will find out the with the help of IP address, with the help of MAC address, it is exactly opposite to ARP. It is exactly opposite to ARP. Exactly opposite to ARP, and we'll discuss later DHCP whenever the DHCP concept is come. That time you will understand this point. Up to here, any doubts? And till now, what we discussed till now, any doubts? What we discussed: reference model, session layer, presentation layer, and application layer. And TCP IP having 4 layers: application, host to host, internet, and network layer. And ARP we discussed, and RR, reverse ARP. Proxy ARP also we have, but it's not required now in CCNA level. We'll discuss at end of the sessions. Till now, any doubts? And tomorrow we have a topics like I'll show you ARC table tomorrow in lab, and will discuss VLANs, trunking, and tagging and encapsulation. We see everything in packet tracers. Okay. Okay. In ARC behind one ICMP protocol work, how it will be work, we'll discuss it tomorrow. Okay. We'll check with proof in labs in packet tracer. Now
Okay.
we'll bind up now. Tomorrow we'll meet again. Till now, if you have any queries, we'll meet again. Now session will be closed. That's the reason I'm telling. If you have any queries, we'll rejoin again.
No.
Okay, fine. Thank you for confirmation.
Thank
Thank you.
you.
Welcome.
Hi,
Bye,
Alim.
bye. Thank you for
Hi,
joining.
Alim. I need to talk.
Okay.
I just sent you the message. Yesterday, I had meeting with the Janus.
Okay. We'll discuss in one
Uh,
to one. Wait. Stop the recording. We'll discuss. Okay.
yeah, okay. Yeah.
Pause the recording.